Now, as I look at this information here, you can see that every IP address that I need to communicate with has a MAC address in my ARP table. This is fantastic. It shows you that whether it's static or dynamic. And normally, obviously, when I'm doing a dynamic means that I actually use ARP requests to get this information dynamically. I had to send out an ARP request to get this. And this is very crucial to understand. Because at some point, if your ARP table becomes corrupted in any way, shape, or form, you're going to be sending data to the wrong MAC address. And transmissions or communication will not happen. It's possible to have this done, and the problem is we don't really think about this communication on a regular basis. We learn about it, we go through our CCNA, we understand it, and then eventually we just forget about ARP because it all kind of works itself. But if ARP does not get the information in its table correctly, because once the information is there, it's there. Unless the information gets timed out or refreshed in some way, shape, or form, that information is there. So you might have to go in there and physically clear out entries in your ARP table so it will send out another ARP request to fill that information in. You can actually do manual entries, which will make them static. And then when you do that, I mean, you could be type in the wrong MAC address, you could be sending data to the wrong PC. And it's definitely possible. And you could have communication coming back and forth. It might be hitting the wrong PC, though. It's possible. Now, based on this, after we've got our ARP done, and we're able to communicate now back and forth from PC 1 and 2, let's go back and re-look at this process all over again. PC 1 tries to communicate with PC 2. Step 1. I'm going to send a ping. Step 2, I'm going to build my layer 3 information, which has my source IP and my destination IP. That's easy to find. My source is going to be this, the destination is going to be who I'm pinging. 3, I'm going to build my source MAC, which is easy. This is my layer 2 information, and my destination MAC, which is not so easy. I need to use ARP to get this destination MAC address. Now, when I use ARP, I have to go back and look in where? The ARP table. If the information isn't in ARP, then I have to do what? An ARP request. Once that ARP request is done, I can continue on by building my source and destination MAC. So technically this comes up and goes here. 7, I can send this off to communication. So let's try this with the MAC address that's already in there. Here's my ARP entry. ARP BB:BB equals 192.168.1.2. PC tries to ping 192.168.1.2. The first thing he's going to do, he has data that he needs to send. He's going to build his layer 3 information, which is what? Source IP, which is 192.168.1.1. The destination IP, which is 192.168.1.2. And now I'm going to encapsulate this with layer 2. My source MAC obviously is going to be AA:AA, which is me. That's who I am. And my destination MAC. At this point, I'm going to look into my ARP table. What part am I looking for? Where am I going in the table? What I'm going to look for? I'm going to be looking for the destination IP address, which is this. 192.168.1.2. When I see that in the ARP table, then I'm going to go over and say, oh, okay, this is BB:BB. And this is how this is done. Let's talk about the default gateway, because there's other things that play a factor in basic communication. When PC1, or in this case PC8, tries to communicate with PC1, we need to understand one thing about this, and PC1 is going to send the communication over to PC8. PC1's in network A. PC8 is in network B. Now remember, I explained that the IP address numbers that we have identifies what network we're on. We have the network number, we have the host number. So PC1, if he's trying to communicate with someone on the same network, like on PC3, he's going to go through the steps that I said. He's going to build the layer 3, he's going to build the layer 2, and in order to get the destination MAC of the layer 2 portion, he's going to look in the ARP table. He's going to do this if they're on the same network. But wait a minute, what if they're not on the same network? Aha! If he's not on the same network, he's not even going to try to look for ARP in that fashion. He's going to send it to what? His default gateway. Now, what is a default gateway? A simple explanation of a default gateway is this. A default gateway means that anytime you're sending data or you need to communicate with someone that's not inside your network and who's not on the same network as you, you need to send it to that default gateway. Now we have to think about the logic here, because what device is going to be the default gateway? That's an interesting question. We have to ask ourselves, well, wait a minute, if PC1 is trying to communicate on someone on a different network, what device do we need? What layer do we need to use? And what type of device do we need to use that communicates between networks? A router. And a router deals with layer 3. Right? So that means my default gateway must be most likely a layer 3 device. Does that mean I can send it to a layer 2 device? Sure. Doesn't mean the traffic's going to get where it needs to go. Now that means if everyone here is on the 192.168.1.0 network, which means this is a network, this is a network, this is a network, this is host. Remember we talked about that? That means this interface of this router needs to be on the 192.168.1 network. So let's give it a 192.168.1.10 address. So PC1 is going to have an IP address, 192.168.1.1. And he's also going to have a default gateway of 192.168.1.10. So whenever he needs to communicate with someone else that's outside of his network, he's going to send it to this address. So now let's take a look at this communication. So in this interface, which is router 1, 192.168.1.10, isn't that much better? PC1 is trying to communicate with PC8. PC1 has an IP address of 192.168.1.1 and a default gateway of 192.168.1.10. Now, let's think about how this communication goes. He's trying to communicate with 192.200.200.8. We'll just make that the address. So this is the interesting thing, because here's how PC1's information is going to be. His source IP and its layer 3 information is going to be 192.168.1.1. That's simple. His destination IP address is going to be what? Well, PC1 knows the destination that he's trying to communicate with. He knows that this is not on his network. So guess where he's going to send it to? His default gateway. What is his default gateway? 192.168.1.10. Well, that makes sense, doesn't it? When we're building out layer 3 information. This is where it gets kind of weird, because you're like, well, wait a minute. That doesn't really make sense to me. Because if I'm sending it to 192.168.1.10, how does it know that it's getting to 192.168.200.200? How does it know that? Well, that is an interesting question. An interesting question indeed. Because our original header is definitely going to have this address in there. So how does this information get to 200.200.8 and keeps this information in there, but yet I'm sending it to my default gateway? This is where Wireshark comes into play. This is where you want to actually look at your traffic and see if I'm sending traffic to my default gateway, how is this happening? I'm a little confused on how we're sending it to here in order to let the router know that it needs to go in this direction. And this is where Wireshark will come into a huge play.